Hello students, how are you? Today let us see some more NCERT exemplar problems from atomic structure. These are very useful for the coming IIT JEE and NEET examination students. Now let us go to these questions. Which among these orbitals 4d, 5s, 4f, 5f and 4p orbitals have lowest and highest energies respectively? The energy of orbital, any orbital depends on n plus L values. It is called Bohr-Bury rule. The orbital with lowest n plus L value will be the lowest in energy. If two orbitals have same n plus L value, then the one with lowest n value will be the lowest in energy, right? And the one with highest n plus L value will be highest in energy. So first we have to calculate n plus L values for all these orbitals. For 4d orbital, n value is 4 and L value is 2. So it is 6. For 5s orbital, 5 plus 0 which is equal to 5. For 4f it is 4 plus 3 which is 7. 5f 5 plus 3 which is 8. For 4p orbital 4 plus 1 which is equal to 5. So these orbitals 5s and 4p orbitals have same n plus L value of 5. So these orbitals, among these orbitals which will be having the lowest energy, the one with lowest principal quantum number. So among these 4p orbital has lower in energy. So this is the one with lowest energy. Now among these which will be having highest energy, it is obvious from these numbers that 5f orbital is highest energetic orbital. So 5f orbital is highest energy. So 4p and 5f, 4p and 5f is present in the B option. So this is the correct one. Okay students. Now let us see the next question students. Arrange the following radiations in the increasing order of their energies. Here the wavelengths are given. Wavelengths are given in different units. Here it is nanometers, micrometers, nanometers and angstrom units. All should be converted into the same units, that is the meters. And then what is the relation between energy and wavelength? We know that E is equal to hc by lambda and E is inversely proportional to the wavelength. Okay. Now let us convert all these into meters. It is A is 300 nanometers into 10 power minus 9 which is equal to 3 into 10 power 7 minus 7 meters, and B is 300 micrometers, 300 into 10 power minus 6 which is equal to 3 into 10 power minus 4 meters, all are in meters, and C is 3 nanometers, 3 into 10 power minus 9 meters, and D is 30 into angstrom units, 10 power minus 10 meters which is equal to 3 into 10 power minus 9 meters. Here C and D have the same wavelength, so their energies are also same. Therefore, C is equal to D. The energy of C is equal to D. And among A and B, which is having the lower wavelength and which is having the higher wavelength? The one A is having the lower wavelength, so it will be having the higher energy. So B is having the lowest energy. So B less than A less than C equal to D. This is the answer for this question. Okay students. Next question is, according to Bohr's theory, the angular momentum of electron in the fifth orbit. One among the Bohr's postulate is the angular momentum of revolving electron MVR is equal to NH by 2 pi. The angular momentum is equal to NH by 2 pi. This formula we have to apply in this. Here what is N value? N is equal to 5. So it is 5H by 2 pi. 5H by 2 pi. So it becomes 2.5 H by pi. The answer is 2.5 H by pi. This is the answer for this question. Next question is the orbitals with stable electronic configuration. We know that half filled and completely filled orbitals are more stable. Now among these, in the A option, P3 and D3, P is having half filled but D is not having either 5 or 10 electrons, so this is not correct. And in B, P4, D4, both the orbitals are not having either half filled or completely filled. So this is also not correct. We know that P orbital can have a maximum of 6 electrons and D can have 10 electrons. In the C option, P orbital is having half filled configuration and also D is having half filled. So this is the correct answer. Now let us see the D option. In D, P is having 5 electrons and D 5. D is having half filled but P is not having the half filled or completely filled. So it is also not correct. So the correct option is C for this question. Now the next question. How many Balmer lines are observed when an electron jumps from n is equal to 5 to n is equal to 1? Electronic transition is occurring from 5th orbit to the 1st orbit. How to calculate the number of spectral lines? It is number of spectral lines is equal to total number of spectral lines is equal to n into n plus 1 by 2, where n is equal to n2 minus n1. This is one formula which we can apply. The other one is number of spectral lines can be calculated by sigma n. Sigma n is, here what is n value? It is 5 minus 1 which is equal to 4. Sigma n means we have to write this number and its lower numbers and add all of them. 4 plus 3 plus 2 plus 1. Total number of spectral lines is 10. By using this formula also we will get 4 into 4 plus 1 5, 4 into 5 by 2, 20 by 2, 10, 10 only here also, and in this also we are getting the same number of lines. Now in this question, how many Balmer lines are observed when an electron jumps from n5 to n1? Balmer lines means it is the second series of lines. The first series of lines in this, the first series of lines correspond to, first number corresponds to Lyman series and second number corresponds to Balmer series, and third Paschen and fourth bracket. So how many Balmer lines are observed in this? There are 3 Balmer lines observed in this electronic transition. So the answer is C. The next question, students. When a radiation with energy 2 electron volts is incident on a metal surface, that means it is the photoelectric effect problem. N number of electrons were emitted. If the radiation with 4 electron volts is incident, then how many number of electrons are emitted? That is the question. First 2 electron volt radiation with 2 electron volts and second 4 electron volts. Now what is the answer? Here the energy is increasing. The energy, we know that the energy is nowhere related to the number of electrons emitted from the metal surface. Energy is independent of the number of electrons emitted. It is which factor which determines the number of electrons emitted? It is the intensity. It is the intensity. Intensity is directly proportional to number of electrons. number of electrons ejected from the metal surface in photoelectric effect. So, here the intensity is not changed, only the energy is changed. So, here by 2 electron volts n number of electrons are emitted, by 4 electron volts also will have the same number of electrons emitted. So, it is option A. Now, what is intensity? Intensity is the amount of radiations falling on unit area per unit time. If the radiation falls on large area, more number of electrons will be emitted. So, here it is the energy which is increased. The energy is nowhere related to the number of electrons emitted during the photoelectric effect. Let us see another question, students. The de Broglie wavelength is related to kinetic energy. What is the relation between de Broglie wavelength and kinetic energy? How to get this? What is de Broglie wavelength formula? Lambda is equal to h by mv. This is de Broglie wavelength. And what is kinetic energy? Kinetic energy, which is denoted also by Ek, is equal to half mv square. Here v square is equal to kinetic energy by m. To kinetic energy by m, and v is equal to under root of 2 Ek by m. Right? Now, let us substitute this in this equation. H by m under root of 2 Ek by m. Now, let us take this m into under root h by under root 2 Ek m square by m. So, it will be h by under root 2 Ek m. Lambda is equal to h by under root 2 Ek m. So, here C is the answer for this question. The relation between de Broglie wavelength and kinetic energy is h by under root 2 Ek m. Okay, students. Hope this video is very useful to you for solving most of the questions. Students, I am going to upload many videos based on different topics in future also. Please subscribe to my channel. Right? Thank you.